The Chesapeake Bay Program is a federal-state partnership working to restore the Chesapeake Bay watershed through science-based restoration. My name is Marisa Baldine. I'll be the moderator for today. I am the communications staffer with the Chesapeake Research Consortium at the Chesapeake Bay Program. And today I'm happy to introduce our speakers. We have John Wolf, who is our GIS team lead with the U.S. Geological Survey, Olivia Devereaux from Devereaux Environmental Consulting, Helen from Devereaux Consulting, and we also have Peter Claggett with the U.S. Geological Survey. So our first speaker will be John Wolf, and I will hand it off to him.
All right, thanks very much. So I'm John Wolf. I'm with the U.S. Geological Survey, as Marisa mentioned. I'd like to acknowledge two of my colleagues from USGS, Scott Phillips and Ken Heyer, who have both been instrumental in the project I'm going to describe today. And that is basically an overview of a fairly recent tools portal that we've created that focuses on targeting resources. Basically going to give you an overview of the purpose and the background behind this project. And then I'll give you a quick tour of the portal itself. So the portal that I'm going to describe is basically a website that the Chesapeake Bay Program and USGS have compiled that is intended as sort of a one-stop shop, if you will, to find a number of decision support tools that have been developed over the years, either by the Chesapeake Bay Program office here or by the many partners that we work with in terms of our goal implementation teams and work groups. The organization is centered around really four main topic areas that are probably familiar to many of you: water quality improvements and water quality decision support tools, those tools that deal with fish, wildlife, and habitats. We have a variety of land conservation tools that are largely led by the Chesapeake Conservation Partnership. And then finally, increasingly in recent years, we've been focusing on tools that are particularly important in a socioeconomic context or in terms of benefits to people. And then we have some overarching topics that cross the bounds of those four categories, particularly climate resiliency at this point, but also diversity, equity, and inclusion. So one of the goals behind this website, this tools portal, is to, in the future, have access to multiple tools that could be used in the context of a given project. So you might want to look for multiple benefits of a particular conservation or restoration activity. These build largely from existing tools. We're not creating anything new, at least we haven't yet for this particular portal. So we're drawing initially from existing tools that we know are being used by partners throughout the partnership. And the current effort is being led by USGS, but we've relied heavily on the involvement of EPA, the Chesapeake Conservancy, and NOAA for some of the estuary and tidal area tools. So why are we doing this now? Well, first of all, we did some user research with some of our stakeholders a couple of years ago that focused in on what could we do better to provide access to geographic information in particular. And one of the main findings of that research was that folks had a hard time finding information on our suite of websites. And so one of the goals here is to create sort of a central portal to find a number of decision support tools that might meet any number of needs. We're also recognizing with the year 2025 coming up, there's a number of deadlines, not only water quality based, but for other outcomes under the Chesapeake Bay Watershed Agreement. And so there's a recognized need to accelerate progress. And so we wanted to bring some of these targeting tools together so that when we're identifying particular practices to put in place or land conservation projects, there might be an opportunity to achieve multiple objectives with a given project. Also, another reason that we're looking at this is that frankly, there's a number of new funding opportunities that are impacting not only sort of the federal folks, but any number of partners that, and so the ability to identify opportunities to achieve multiple benefits with some of these new opportunities, the infrastructure law, the America the Beautiful program, some of these other federal programs, but also some of the state and local government activities. We wanted to be able to steer folks in certain directions if they were so inclined. And then we have a growing interest from stakeholders and how can we find out more about these tools and also learn how to use them, which is another finding of our user research. So I'm going to jump over now into the actual website itself. It's called Accelerated Conservation and Restoration. So this is the homepage of the website. I think we're sharing the URLs to these tools as part of this webinar. But anyway, so the homepage is basically gives you an overview of the website itself, some basically information about what it's intended to address, how it's organized and so forth. A lot of the information I just covered. And then there are 4 tabs along the top of the website, again, organized based on those topical areas of focus: water quality, fish, wildlife habitats, land conservation, and benefits to people. So there's a lot more content in this site than I can possibly touch on today. So I'm going to just give you a few highlights, show you how it's organized, and maybe just touch on a couple of the tools so you get a feel for what's in here. So if I go to the water quality improvements tab, and this is consistent for each of those 4 topic areas, you get a brief description of the need. Why would people use a decision support tool for this particular topic? Some examples of existing tools, and then how we envision some future evolution of this website and other targeting and decision support tools. And then the other thing that's consistent across the 4 topic areas is you'll see this kind of a flow chart or decision tree that is intended to help a user determine what kind of decision support tool might be most appropriate for my needs. And so if you look through here, the very first question in this case leads you to a suite of information that deals mainly with the water quality monitoring network, particularly in the non-tidal areas of the watershed. But you might have interest in agriculture, or you might have interest in nutrient and sediment pollution or toxic contaminants. And so that decision tree is sort of oriented to help you find information. And then below that, and again, this is consistent for each of the 4 tabs, you have basically a list of topically oriented decision support tools. So this very first one, it deals with non-tidal monitoring. And one of the choices here, and I'll just pick a couple of examples that show you the different types of information, is to click on the USGS non-tidal monitoring network website, which is just being updated, but this is a story map that basically describes the non-tidal site in terms of loads and trends to the bay, total nitrogen, phosphorus, suspended sediment, and so forth. I'm going to jump back out of that. Other water quality tools, you're going to hear more in just a couple of minutes about the Chesapeake Assessment Scenario Tool, so I'm going to jump right past that. But there's other tools in here that are aligned with various programmatic objectives. There's a tool dealing with something we refer to as most effective basins. And that actually leads you to a mapping application that shows those areas throughout the watershed that are likely to have the greatest impact in terms of putting in practices in terms of the impact to the dissolved oxygen conditions in this main stem of the bay that's shown here in red. So that's the most effective basins, but there's other tools here. Priority agricultural watersheds not only looks at impacts to the bay, but also looks at impacts to local waterways. So in case you're interested in local impairments as well as Chesapeake Bay impairments, there are a number of modules in here that actually come from another tool called the Watershed Data Dashboard. Has information on restoration efforts, on BMP or best management practice implementation, and as well as the source of pollution. And a lot of that information actually comes from CAS, the tool you'll hear about next. So I'm going to jump over now to the fish, wildlife, and habitats. Again, this is organized the same way with an overall discussion of the need, and then existing tools, how enhancements are planned for the next year, And then when we get down into the listing of habitat, fish, wildlife, and habitat tools, for the most part, these are aligned with the outcomes that are associated with our vital habitats goal under the Chesapeake Bay Watershed Agreement. So we have things like forest buffer, restoration and protection targeting. This is a tool that has been developed with the Environmental Protection Agency Region 3 in conjunction with each state. And it's basically prioritizing the riparian areas in each state for their suitability for riparian restoration or protection. Other tools under habitat are wetland restoration. We have some tools that are actually cross topic in nature. This is a mapping composite for restoration. We also have one for conservation. And then there are some decision support tools that are managed by some of our partners. Here's the U.S. Army Corps of Engineers and their Comprehensive Water Resources and Restoration Plan, the National Fish and Wildlife Foundation, and so forth. And then there are a number of tools that are really the focus of individual outcomes or work groups under the vital habitats goal: fish passage, fish habitat, stream health, brook trout. So these are very topically focused habitat-based tools. I'm going to go over to land conservation next. Again, these are tools that are aimed at helping identify important lands for conservation throughout the watershed, largely developed either by the Chesapeake Conservation Partnership or in partnership with them. And some of these tools or these models are actually from the Chesapeake Conservation Atlas. Some of you may be familiar with that. But it has things like the forest model, important forest lands throughout the watershed, important farmlands, looking at things like prime and productive soils, important habitats. And so these are sort of a network of hubs and corridors of important habitats throughout the watershed. There are tools here for heritage areas. This is looking at it from a cultural heritage perspective, National Register of Historic Places, national trails, and so forth. And then we have the Chesapeake Healthy Watersheds Assessment that looks at the health and vulnerability of watersheds throughout the Chesapeake Bay Basin. The last tab, increased benefits to people. Again, the same overall organization. We have tools that summarize ecosystem services at a county scale throughout the watershed. There's some other information here that's related more to our stewardship goal implementation team. In this case, we have information related to environmental literacy. There is an individual dashboard that deals specifically with environmental justice and equity issues and has a lot of the information that is in the National EJ Screen tool, but customized for the Chesapeake Bay. And then information on public access, climate resiliency, organizational capacity, something we're relatively new that we're trying to map and identify important organizations throughout the watershed, partner organizations. And then finally, a mapping tool dealing with the scientific research footprint around the watershed. Where are USGS and other scientific entities actually conducting research throughout the non-tidal and tidal areas of the watershed? So I'm going to leave it there. Happy to take questions or questions at the end.
No questions, right?
Okay. And I'll stop sharing.
And next, we'd like to introduce Helen Golomowski from Devereaux Consulting. She's the watershed data analyst who supports the Chesapeake Bay Program's projects related to decision support tools for water quality improvements in the watershed.
Great, thank you. So yeah, I'm Helen Golomowski and Olivia Devereaux is also here in the room with me today. So we'll be sharing about what CAST is and how you can use it. Go to the next. So CAST is short for the Chesapeake Bay Watershed Model and is a comprehensive synthesis of knowledge that can help direct management. The management community largely relies on CAST to understand and improve water quality conditions. Technical information about water quality loads and trends is used to improve and assess modeled predictions. The arrows on this visual represent the various flows of information that go into CAST. Observed data are used to develop watershed studies and statistical models based on priorities identified by the management community. Watershed studies and statistical models provide technical information that are communicated to the management community and used to improve CAST. The management community uses CAST to develop management strategies, and CAST assesses predictions and performance against observed data. The states use CAST to track best management practices or BMP implementation toward the Chesapeake Bay total maximum daily loads or TMDLs. On December 29th, 2010, the U.S. Environmental Protection Agency established the TMDL, which is a historic and comprehensive pollution diet to restore clean water in the Chesapeake Bay and the region's streams, creeks, and rivers. Phase 3 watershed implementation plans are the roadmap for how to get from 2017 to 2025. Pollutant load reductions in nitrogen, phosphorus, and sediment from BMPs are modeled in CAST online at cast.chesapeakebay.net. And CAST is the watershed model used for annual assessments and planning, and the official documentation of the model is on the CAST site. Now I'll share some history about CAST and how we got to where we are now. The first version of CAST was launched in 2011 at the request of MDE to provide local jurisdictions, such as counties, with a tool to provide input into the Bay TMDL Phase 2 WIP process. The Bay program decided that the tool was useful and should become a Bay program tool available to the entire Chesapeake Bay watershed. CAST can be accessed online for free and now has over 1,500 users. CAST is used to develop implementation plans and show the loads reduced for annual progress assessments. CAST allows local communities to generate results and can help states, local governments, and others identify which pollution prevention strategies and conservation practices make the most sense given their available resources. And the outcome of all this is that the model became more transparent and could be used by anyone. So CAST can be used to develop a plan with multiple BMPs across a large area, for example, not a single farm, and determine load difference from a present condition. It can be used to understand the data that is used to inform CAST load estimates, prioritize which BMPs have the most effect on loads, evaluate cost effectiveness of BMPs, and assess where a BMP would have the most load reduction. This is a list of the current geographic scales available in CAST for creating scenarios and reports. You can gather data at a scale as broad as the entire Chesapeake Bay watershed or as fine as a land river segment. So who is CAST for? CAST is for the technical managers within jurisdiction agencies who plan and report for the 2010 Bay TMDL. It's also for local watershed organizations, local government planners, and federal, state, and academic researchers. This pyramid represents the level of information available on CAST and the audiences that are appropriate to utilize this information. The blue box outlines the area on the scale of information density and information synthesis that CAST embodies, along with the audience types that will find CAST the most useful. So that being said, CAST may be too complicated and weedy for the general public, but would be perfectly suited and useful for the management community to compile technical documents. So this visual here can be found on the Develop a Plan page in CAST and outlines the basic steps to developing a watershed treatment plan using CAST. The first step is to establish programmatic goals, which can be categorized into loads, co-benefits, and costs. Co-benefits refer to ecosystem benefits that are outside of the nitrogen, phosphorus, and sediment reductions that are typically targeted due to the TMDL requirements. CAST provides information about co-benefits, but when you're running reports in CAST, the main goals that are focused on are those loads and cost goals. So once you've established your goals, the next step is to translate these goals into BMPs. You can then test to make sure your recipe of BMPs reaches the numeric goals by inputting them into a scenario in CAST, running a report, and analyzing the results. From there, if the goals were not met, you can revise your plan and run through the process again. If the goals were met, then your plan can be finalized. So these are just some typical questions that can be answered with CAST. One, what is the load reduction from a BMP implemented in my community? What is the current land use, land cover in my community, and where can I quickly access the data? How do I find out how my pollutant loads and land uses are projected to change for various 2025 development scenarios for my community? Which BMPs are currently in the model for my community? How can I estimate which of those BMPs were implemented as part of my MS4 permit? And then some more questions are, how do I find out what the load reductions are from BMPs implemented and planned? Which BMPs are most cost effective? What are the co-benefits associated with each BMP? How can I show the results of my analysis in a way that makes sense to non-technical people? Which BMP will give me the most load reduction? And where should I target BMPs to generate the most load reduction? You can find lots of information about BMPs in CAST, such as sources of BMP data, the process for introducing new BMPs for use in scenarios, and crosswalks to NRCS and other practice names. This is all available from the BMPs page, which is another page you can get to right from the CAST homepage. So CAST has a new interactive tool called the Ecosystem Benefits Browser. This tool visualizes and summarizes the goals, outcomes, and co-benefits associated with CAST BMPs. If you open this page in your web browser, you can select different goals, outcomes, or co-benefits from the list on the right-hand side, or you can click on the bubbles in the graph to take you to learn more about those benefits and which BMPs are associated with them. There are a few different ways to target load reductions, and CAST can help you with all of them. So one way is to target load reductions by location. The map in this image on the left shows a gradient of loads in pounds per year. The darker purple areas have higher loads and the lighter purple are lower loads. So this map can help you determine what locations have the highest loads, so those areas can be targeted for BMP implementation. The next way you can target reductions is based on which BMPs you choose to select. So CAST has tools that can help you determine which BMPs will have the highest load reductions for the lowest costs. And another way you can target reductions is by land use. Some land uses are more prone to runoff of nutrients or have more nutrients applied to them and therefore could benefit from having BMPs implemented. So once you've determined which BMPs you plan to use and where or what land uses you plan to implement them on, you can load them into a scenario and CAST will show you what the resulting loads are. So these screenshots are of the graphing tool in CAST, which automatically creates a visual for you to see what the estimated loads are for your scenario. And you can easily at a glance check to see if your target loads have been achieved or if more BMPs need to be implemented. This is a screenshot of the trends over time page on CAST. This page generates graphs that can show you a variety of different things, such as animal counts, nutrients applied, BMPs implemented, and more. So this example is showing the nitrogen nutrients applied in Shenandoah, Virginia for the years 2010 to 2025. The data for 2025 are from the phase 3 WIPs, and you can play around with the selections on this page to generate graphs for other counties, states, and nutrients. So this will just be a list of the resources that are available within the CAST site, some of which we touched on already today. So from the CAST homepage, you can click on develop a plan to find steps, goals, co-benefits, and financing resources. You can always click on the contact us option at the top of any page of the CAST site to contact myself or Olivia for one-on-one user support. Depending on the level of assistance needed, we can get back to you via email with an answer or schedule a meeting to go over any questions you may have. The CAST learning dropdown at the top of any page on CAST can take you to user documentation with tips on getting started with CAST. Here you can also find free training videos, which include any of our past CAST webinars, as well as shorter videos to help you get started with CAST, like step-by-step demonstrations of how to create scenarios and reports or graphs. And in addition to this, on the free training videos page, you can find the information about any upcoming webinars we're planning, so you can tune in live with us and have the opportunity to ask questions at the end. The source data is an Excel sheet, which you can download and has data tables, including information on load sources and agencies, BMPs, animals, geographic references, delivery factors, and more. So this is an excellent resource and one that I personally use often. And then you have the BMP cost data, which I touched on earlier as well. And if you have any questions, you can also contact myself or Olivia directly.
Just a reminder, if you have any questions throughout the presentation, please put them in the question and answer box. If there's no questions at the moment for CAS, we will move on.
Thank you, Helen. And next, I would like to introduce Peter Claggett. Peter is a research geographer with the U.S. Geological Survey. Peter's research focuses on characterizing past, present, and future land cover and land use conditions throughout the watershed.
Thank you. I'm going to be talking about our high resolution land use land cover data that has been recently created and recreated for the Chesapeake Bay. A lot of organizations have been part of this. USGS is one of them. The Chesapeake Conservancy's Conservation Innovation Center has been one of the main developers of the data, along with the University of Vermont's Spatial Analysis Laboratory. The data we have is 1 meter resolution now. What we have been using for the last 20 years has been 30 meter resolution national data, and that's what you see on the left-hand side. On the right-hand side, you see an example of our 1 meter data. And you can see not only is there a lot more granularity and detail in the 1 meter data, there are also a lot more streamlines, those blue lines, because we can detect those as well using a complementary project that we're working on to develop a very detailed streamlined data set. I'm going to be talking about both land use and land cover. They're different terms, but complementary terms. Land use is how humans use the land. So that would be residential land, agricultural land, recreational land. And land cover represents the physical characteristics of the land surface. Is the land surface impervious? Is it tree canopy? Is it herbaceous vegetation? And for environmental applications, particularly those pertaining to water quality, you really need to understand both land use and land cover. Another reason you need to understand land use land cover is that some changes that we observe that are relevant to water quality are land use changes, but they don't show up in a land cover map. So on the left-hand side, you have land cover change and new development with buildings in red, roads in black, impervious surfaces, other like dry parking lots and driveways in gray. And on the right-hand side, you have that change, but you also have this light yellow color around these buildings. And what that's referring to is that the land that had previously been used for agriculture is now being used as turf grass. So all the herbaceous land in the residential lot, in individual lots, changes use. It may not change cover type, but it changes use. And that's important because these herbaceous lands, you call them low vegetation or herbaceous vegetation, they can really vary in terms of their impact on the bay. They can be one of the lowest loading, lowest polluting land uses, like land undergoing natural succession. So if a forest has been cleared and now it's growing back, that doesn't yield a lot of pollutants to the waterways. But if we look at other lands, like if it's a field of corn, it's one of the highest polluting land uses we have in the watershed, or if it's a turf grass in somebody's backyard, it may or may not yield a lot of pollution depending on how they manage fertilizer, how many times they fertilize, when they fertilize, etc. So from a land cover perspective, all these areas are the same. From a land use perspective, they're very different. We've created a combination of land use land cover data for not just the entire Chesapeake Bay watershed, but for all counties intersecting and adjacent to the watershed. So instead of 64,000 square miles, we've mapped an area 99,000 square miles so that the data are most relevant to local governments making land use decisions. We have 12 classes of land cover, 54 classes of land use combined with land cover. And this is complete coverage for 206 counties. Right now, we've produced the data for 2 years, 2013-14 and 2017-18. And soon we'll be producing the 2021-2022 data. These data, the raw imagery used in the classification, are collected via remote sensing. We use the plane in the upper right for remote sensing. There's other instruments that can be used, but it's actually the Department of Agriculture that collects aerial photography for the whole nation about every 2 years. And so we're leveraging those data as our raw imagery. Coupled with that, we're using LiDAR data. Now, unlike a photo, unlike a camera that's on the bottom of a plane taking pictures, LiDAR is an active sensor, sends a beam to the ground surface. That beam is reflected back and received by the plane. And what is produced with that process is basically a 3D rendering of the Earth's surface. And that 3D rendering is really important because it tells us whether an area is a building or it's a parking lot, or whether it's a field or a forest. It's really important to have that LiDAR information where we can get the height of objects, and that's used in our classification process as well. We track for every county the vintage of LiDAR, and that's the map on the right-hand side. So with the aerial photography and the LiDAR, all that information is combined and used with object-oriented classification software to produce a land cover map. So now we're mapping the areas of trees, the areas of herbaceous vegetation, the areas of impervious surface. And then once that's done in an automated fashion, a team of folks manually correct the data to bring the accuracies up from an 80% accuracy range to 90–95% accurate. Here's an image of Frederick County, Maryland, and the southwest portion of the county. The gray is impervious, the dark green, a lot of that's forest, some of it's agriculture, the light green or light beige is agriculture. Here's what it looks like from a land cover perspective, and you can see that most of the area is light green, meaning it's low vegetation. We have not yet differentiated whether it's cropland or turf grass, and that comes in the second phase of the project where we integrate land use information collected locally and other ancillary data on roads or recreational lands, parks, protected areas. We integrate that with the land cover data to get land use. We have over 50 land uses identified and mapped throughout the whole region. This is a list of those. Now, it's very hard to color code a map with 50 different colors and make any sense of it. And so to aid both our interpretation and the public's interpretation of the data, we've simplified it by aggregating the classes up to a generalized 18 classes. And then what you can see here is Western Maryland. This is Garrett County in Western Maryland. This is what the 18 classes look like for this area. Again, there's a lot of granularity, a lot of detail, particularly in urban and developed settings that you can perceive with these data. Well, one of the most important things about this data set, and that's making it unique from other data sets, is we are tracking change. We're not just mapping every 4 years, but we're mapping and trying to be very accurate in what's changed over time. So here we have a 2012 Google Earth image of an area This is a 2018 image collected by the Department of Agriculture for that same area. And here's our map for 2013-14 of that same region. And here we have the same area mapped with 2018 land use. So we are capturing all these new buildings. We're capturing change in use, change in cover for this whole area. And the magenta streamlines you see, that's just showing you a riparian area along the stream network and how having this high resolution data really helps you figure out where you may have gaps in that riparian area, where you have tree, which would be tree planting opportunities. So to summarize some of the unique qualities of these data, very high spatial resolution, captures 45% more impervious cover than the previous data we were using. Very high categorical resolution. We have about 50 classes instead of the typical like 15 or 20 classes. We're producing these data every 4 to 5 years and hope to continue that out through 2030. The anticipated accuracies for some of the most important classes are going to be greater than 90%, and the area covered is pretty extensive. We hope that these data will be useful for folks assessing current conditions for any geography they choose because they are so high resolution, and also used to identify opportunities for restoration and conservation, to prioritize those opportunities, and to establish goals based on current conditions. So for example, a jurisdiction could use these data to assess how much tree canopy they have in their urban areas, set goals for increasing that, and then track it through time, track their progress using our data. We can also monitor changing conditions anywhere throughout the watershed over these time periods that we're mapping. So here's an example for the 43 counties in Pennsylvania where we've assessed what the land cover conditions are on the left-hand side and then change over time on the right-hand side. That can be done, again, for any area, anywhere in the region. And then the Forest Service has used these data to create tree cover change fact sheets. So for every county, they'll be releasing these very shortly. This is a draft version where you can look at patterns of change in your county, what's changing, what's causing it. Very informative way of communicating that information. The Chesapeake Conservancy are using these data to work with farmers in Pennsylvania to identify opportunities for planting trees and where planting trees may provide the most environmental benefits. And then when we look at the data for the entire region, this is impervious cover. We can see on the left-hand side where we've got the most impervious cover, which is the dark brown, tends to be in the urban areas. And then on the right-hand map, we can see in blue where the change, the increases in impervious cover have occurred. We can drill down and look very closely at the landscape and see where do we have these increases in impervious cover. And these blue colored areas are catchments, small watersheds. And we can use some of our online viewers that are available to the public to drill down even further and look at, well, what happened? Why is impervious cover increasing? In this case, on the Eastern Shore, it happens to be the development of a lot more chicken houses in this particular community. And then looking at tree cover change, we can look here in upper Pennsylvania, lower New York, and see why do we have a lot of tree cover conversion in this area. And if we look closely with the change viewer, we can see that areas have been cleared for forestry. Now these areas are probably going to grow back, and so it's just a temporary disturbance. But again, you can identify exactly what's going on via these online viewers. This is the website where we host the data. There's 2 viewers looking at what's there today, the 18 different classes, and then you can also look at change over time. All the data are downloadable by county through this site, and there's documentation as well through this website. A lot of people worked on this. I'm not going to name them all, but they're listed here. And then myself or Katie Walker at the Chesapeake Conservancy can field questions about these data if you have any today or later on. Thank you.
Thank you so much, Peter. We do have one question for you. How do you distinguish between ephemeral and perennial streams at that scale?
That's a really good question. And I can tell you that no one's yet come up with a great way to do that. That's going to be a upcoming and ongoing research project to figure out the best way to do that. USGS as an agency is looking into this issue as well. And what I can tell you is that the future of these types of data, these stream data, are probably going to be probabilistic estimates of flow and flow periodicity, whether it's an intermittent or perennial or ephemeral stream. And even USGS is moving away from just calling something perennial or intermittent because it also varies over time. It varies with climate change. And so we're in for a probabilistic future when it comes to these data.
Thank you so much, Peter. I don't see any other questions for Peter at this time, but we do have a couple other ones that have appeared in our Q&A box. And just want to remind folks that we'd be happy to take questions for any of our speakers. Just click on that Q&A at the bottom of your screen and just type in your question. So for John, how do web portals like Maryland DNR's Eyes on the Bay, the Chesapeake Monitoring Cooperator's Data Explorer, and EPA's How My Watershed fits into this portal?
So that's a great question, one that we've received really since the beginning of us developing this targeting tools portal. The short answer is we're interested in all three of those, as well as other decision support tools. We decided initially to focus on decision support tools that were applicable across the Bay watershed, so multi-jurisdictional tools. Eyes on the Bay is a wonderful resource. It's specific to Maryland. We'll be expanding the scope of the targeting tools portal to capture some of these other things. The monitoring cooperative is another really important monitoring data set that supplements the work of the USGS and other monitoring activities. And the How's My Watershed, the EPA tool on that, we actually draw from some of the same data sets that How's My Watershed includes. For example, the 303D impaired waterways list that populates How's My Watershed is also populating our priority agricultural watersheds tool. But we are very interested in expanding the scope as time allows to include these other tools that are not, say, jurisdiction-wide or directly connected to the Chesapeake Bay Program Office activities.
Thank you. We have another question that actually I would direct to any of our speakers. Are plastics and microplastics and PFAS data being collected and monitored in any of the maps?
So in terms of the targeting tools portal, I mean, we certainly recognize the significance of this topic. USGS is pursuing it to some degree. We do not yet have it in any of the existing decision support tools that I'm aware of. Interested in learning more about the possibilities there and what other resources might be available. I'm not sure if CAST at all deals with this topic, or the land change or land cover wouldn't.
CAST is not yet. What we need is to have the levels of PFAS monitored for a little bit longer period of time in our waterways, and then we could create some maps that show those levels of PFAS and how we can reduce those levels. So we need a little bit more monitoring information in order to include that in our tools.
Peter, I believe this question is for you. Does the land use data differentiate between pasture and hay?
Yes, it does. Those are two separate classes, and we also differentiate whether it's like barren cropland or herbaceous cropland. Same with pasture. And we use for those data, we have to rely on some national information, but we're refining that distinction even more with the 2021, 2022 data. And when we make refinements as we move forward in time, we will go back through time and apply those refinements to the previous year's classifications so that there's kind of consistent change over time. And when you look at change, you're not looking at a difference in classification technique. You're looking at actual change on the ground. But yes, we do differentiate those.
So there's some additional work that's done for the data that goes into CAST, which is we take the differentiation that Peter provides for hay and pasture and those other land classes he mentioned. And then we incorporate the data from the National Agricultural Statistical Service, that's USDA's annual survey and censuses. And we take all of the crops and start to parse out the agricultural areas that Peter's team has identified into those various crop types and pasture types. So we get down to quite a level of detail that you may not be aware of when you're just looking at sort of the aggregated information available on CAST.
Thank you. I have another question for Peter. Can you discern legacy sediments behind old mill dams?
I don't mean to laugh. It's a good question. That is really granular. And so in our data, we haven't done that. We haven't tried to do that. It may be possible with LiDAR, especially looking at, in detail with 1 meter LiDAR data. But I don't even know. It's a very interesting idea.
Thanks, Peter. All right, well, thank you so much to all of our panelists today.
Yeah, thank you to our panelists. And as a reminder, we're going to email everyone all of the resources that were listed in the slides, and the recording will also be available on our YouTube channel in about 48 hours. That's it. Thank you, everyone.